Welcome geometry students to the homework help video, page 91, numbers 1 through 22, skipping numbers 17 and 21. Let's go ahead and get started. Please get out your homework, please get out your pencils, calculators, and turn to page 91 in your book, and let's get started. Numbers 1 through 6 are matching, and we're reviewing what I taught you the other day, which would be let me turn back a page here, the properties of equality and congruence, the reflexive property, symmetric property, and transitive property. And we're also reviewing the addition, subtraction, multiplication, division, and substitution property, okay? And so that's what we're doing with these matching problems, okay? All right, measure of angle DEF equals the measure of angle DEF. That is an example of the reflexive property. The example I gave you in your notes was AB equals AB, and the reflexive property, of course, would be, let me slide this over here, looks like the reflexive property would be letter B. Let me scribble that, letter B, there we go. Let's take a look at number 2. PQ is congruent to ST, and ST is congruent to PQ. That would be an example of the symmetric property. In your notes, I gave you the example AB is congruent to CD, and CD is congruent to AB. So that would be symmetric. That would be letter E. Letter E. All right, number 3. XY is congruent to XY. So that's going to be the reflexive property. And notice it's a congruent symbol. So the reflexive property of congruence. Here it is, letter D right here. Letter D. All right, number 4. If JK is congruent to K and K is congruent to L, then J is congruent to L. Now that's going to be the transitive property. Now would it be transitive of equality or transitive of congruence? Well, ask yourself, do we have congruent symbols here or equality symbols? We have congruent symbols, so we're dealing with the transitive property of congruence, which is letter F. All right, if PQ equals QR and QR equals RS, then PQ equals RS. Notice that would be transitive, and notice we have equal signs, not congruent signs. So it would be the transitive property of equality, which is letter C. Letter C. And then number 6, if the measure of angle X equals the measure of angle Y, then the measure of angle Y equals the measure of angle X. Now that's just like number 2, if PQ equals ST, then ST equals PQ. Only up here we didn't have equals, we had congruent symbols. Down here we have equality signs. So notice number 2 was symmetric property of congruence. So number 6 would be the symmetric property of equality, which is letter A. Letter A. Okay, so that's numbers 1 through 6. Just a good review of the symmetric, reflexive, and transitive properties. Okay, numbers 7 through 8, the directions say for you to, let me take a look here, name the property that the statement illustrates. Okay, we have angle ABC is congruent to angle ABC. Now, first of all, it's going to be a congruence property because we have a congruence symbol. Now, would it be reflexive, symmetric, or transitive? Well, it would be reflexive. Because whenever it's something is congruent to something and they're identical, then that's going to be reflexive. So it's the reflexive property of congruence. All right, let's take a look at number 8. The measure of angle B equals the measure of angle D, and the measure of angle D equals the measure of angle F. Thus, the measure of angle B equals the measure of angle F. Now, notice it's equal sign, so it's definitely going to be one of your equality properties, and it would be transitive. When you go from B to D to F to B to F, that's transitive, so it's going to be the transitive property of equality. Okay, number 9, if GH is congruent to JK, then JK is congruent to GH. Now, they simply just swapped places. GH congruent to JK, JK congruent to GH. So that's definitely going to be your symmetric property. However, notice it would not be equality, it would be congruence because we have congruent symbols. So we are looking at the symmetric property of congruence. Symmetric property of congruence, and that takes care of numbers 7, 8, and 9. Okay, let's take a look at numbers 10 through 15. Now, the directions for 10 through 15 state, use the property to complete the statement. So now we're going backwards. Before they were giving you examples and wanting you to name the property. Now they're giving you the property, and they want you to, let me get my pen ready here, and now they want you to write in what would go in that blank. For example, the reflexive property of equality. Well, if you'll look in your chart or your notes that I've given you, reflexive property is when you have AB equals AB or angle A equals angle A. So we have JK equals JK. And actually, instead of writing, I'm going to go ahead and get my eraser out here and just erase the answers. So JK equals JK. All right, moving on to number 11, symmetric property of equality. Okay, if the measure of P equals the measure of Q, then the measure of Q equals the measure of P. That's symmetric when these two swap places. Number 12, transitive property of equality. Now look, students, we have AB equals BC, BC equals CD, so then we would state AB equals CD. So AB equals CD. The reflexive property of congruence. Angle GHS is congruent to angle GH. Oh, I said it's GHJ, excuse me. Angle GHJ is congruent to angle GHJ. Okay, that's what reflexive is. Look up here at reflexive property of equality. JK equals JK. All right, symmetric property of congruence. If this, then this. Well, symmetric is when you swap places. So if we're saying XYZ is congruent to ABC, then we would have started off with if angle ABC is congruent to angle XYZ, then angle XYZ is congruent to angle ABC. Transitive property of congruence. GH is congruent to IJ. And then notice down here they have GH all the way to PQ. Now think that through. I would have to say GH is congruent to IJ. And then I'd have to say IJ is congruent to PQ. Wouldn't I? See if that makes sense. Watch. Let's see if that works. GH is congruent to IJ. IJ is congruent to PQ. Thus, GH is congruent to PQ. So what you'd want to put in, hold on one second, what you'd want to put in these two blanks here would be IJ and PQ. All right? Hope that helps. Let's move on. Numbers 16 and 18. Now in number 16, the directions say, name the property that the statement illustrates. So here's what I have. Are you ready? AB equals CD. Then notice I add the same thing to both sides. I add EF to one side and I add EF to the other side. Well, according to what we studied in class, that would be the addition property of equality. The addition property of equality. Okay? All right. And then number 18, if x, y equals yz, then, now look what we did. We took one side, multiplied it by 3, took the other side, multiplied it by 3. So just like up here, we added EF to both sides, so it was called the addition property of equality. Well, here we're multiplying 3 by both sides, so we would call that the multiplication property of equality. The multiplication property of equality. Okay, moving on to number 19. You might have to look in your book. It's a little blurry there. In the diagram, the measure of angles 1 and 2 equals 132 degrees. And the measure of angle 2 equals 105. Complete the argument to show that the measure of angle 1 equals 27. Now, watch what they do. Notice up here they gave you this information. So they wrote it right here, and they said that's your given. Okay? Then notice they gave you this information right here, right up here in the problem. See it? Right there. And so we said that's given. So we knew these two things here were true because they were given to us in the problem up here. And that's why the reason that we gave was given. Both of these two things were given to us. Now look what we do. We do something here. Do you see step 1, the measure of angle 1 plus the measure of angle 2 plus the measure of 132? Now look at this step. Notice the measure of angle 1 is still the measure of angle 1. Notice that the 132 is still 132. But look what we did for the measure of angle 2. Look what we did. We put something right here for the measure of angle 2. No longer do we have the measure of angle 2. Instead, we put 105 degrees. Well, students, would you please think for a second, in mathematics, when you put something in for something, don't we call that substitution? Sure we do. We call that substitution. When you picked up 105 degrees and you put that in for the measure of angle 2, and by the way, how did you know you could do that? Because of this right here. We knew the measure of angle 2 was 105. So because we knew that, we could cross off angle 2 and we could put 105 degrees. So that's called substitution. You substituted that in for the measure of angle 2. Now, let's see if you can figure the next one out. The measure of angle 1 plus 105 equals 132. Now I have the measure of angle 1 equals 27. Well, you know what I think we did? I think we subtracted 105 from both sides. If you subtract 105 from this side and subtract 105 from this side, these cancel out, and you're left the measure of angle 1 equals 27. So you subtracted 105 degrees from both sides. That's where we got this right here. We subtracted 105 from both sides. So we call that the what property? We call that the subtraction property of equality. Let's take a look at number 20. Number 20. In the diagram, AB is congruent to FG and BF bisects AC and DG. Complete the argument to show that BC is congruent to DF. All right? Now, here we go. BC is congruent to AB. Let's come over here. Let's actually pick up our information here and let's write it on this diagram. AB is congruent to FG. Okay? So I know that this segment here is congruent to this segment here. All right? So that's pretty obvious. And BF bisects AC and DG. So I know this is congruent to this, and I know this is congruent to this, okay? Because it says right here, BF bisects this segment and this segment. So I know that this segment is congruent to this segment, and this segment here is congruent to this segment. Now, how can I state, come on, think this through, students, how can I state that BC, here's BC right here, is congruent to AB? Well, because what did I state up here? I stated that BF bisects AC and DG. So I can state very easily it's the definition of a what? It's the definition of a bisector. Guys, the definition of a bisector is that the line bisects a segment right in half. So how did I know that BC is congruent to AB? Because definition of a bisector. Now, how do I know that AB is congruent to FG? Hey, wasn't that given to us right up here? See that? Look, it was given to us. AB is congruent to FG. AB is congruent to FG. So the reason I can write that is I can simply state it's one of my givens. Now, how can I state that FG is congruent to DF? Here's FG, and here's DF. How do I know that this one segment that has two slashes is congruent to this over here? Well, once again, guys, it's the definition of a bisector. Remember, look at your given up here. Look, we were given that BF bisects AC and DG right there. BF bisects DG. So we know it's the definition of a bisector. And then now I can state that BC is congruent to DF. Now be really, really careful here. How do I know that? Well, watch carefully. This is really tough, okay? This is not easy, but watch. Look what I have right here. I have BC is congruent to AB. AB is congruent to, are you watching? Watch this, students. BC is congruent to AB. Got it? And then AB is congruent to FG. Got it? And then FG is congruent to DF. So think about it. If BF is congruent to AB, and AB is congruent to FG, and FG is congruent to DF, then I can definitely state that BC is congruent to DF by the transitive property. That's transitive. Transitive property. I hope that helped. I know it's not easy, but that's how you would do that. All right, number 22. Using the properties of equality. In the diagram at the right, the measure of WPY is equal to the measure of XPZ. So notice there's one little red mark here and one little red mark here. This angle with one dot and this angle with one dot are congruent. Okay? Complete the argument to show that WPX is congruent to YPZ. All right. Now look at this very carefully, okay? Sorry, students, hold on one second. Now this is a pretty tough problem, so really pay attention and let me help you here, okay? All right, here we go. Now please watch carefully. First of all, notice right here, this is automatically you're given. They've already told you that, and that's true. It was given to you right up here, so we know that you're given. Now here's your next step. WPX, I'm going to highlight it for you. WPX, that big angle, equals this angle here plus this angle here. And that makes sense. Okay, remember when you have an angle like this with a ray coming off of it, if you take this angle and add them together, it gives you the whole angle. And we had a name for that, and what we called that was the angle addition postulate. So angle addition postulate. We learned that back, I don't know, so many weeks ago. Now it's the same thing here. The YPZ, that big angle highlighted in red, is the sum of these two angles here, that little angle there and that little angle there. So we're adding two angles together and getting a bigger angle, and we call that the angle addition postulate. So not too bad. I know you probably wouldn't have thought of this on your own. It's the first time we've really looked at proofs, but we're going to go over these a lot this year, and I will help you, okay? Now, look at this. Do you see this right here? Notice I have WPY, and I have WPY right here. And notice on the right side I have XPZ, and down here I have XPZ. Look what you added to both sides. You took this up here, and you added YPX, and you added YPX. So you added the same thing to both sides, okay? Remember back here a couple problems ago, let's see, in our homework tonight, right here. Remember we had AB equals CD, and then we added EF to both sides. So when we added the same thing to both sides, we called that the addition property of equality. Well, it's the same thing here. We're adding the same thing to both sides. So we're going to call that, or right here, excuse me, we're adding the same thing to both sides. We're going to call that the addition property of equality. And we learned that in class yesterday. All right. And then lastly, this is pretty cool. Hopefully you've written all this down, because I'm going to clear it. If you haven't, just back it up and watch it again. Okay, but this is really cool. Look at this. Okay, this last reason where we got this from right here is substitution. You might be like, Mr. Earhart, where do we get substitution? Well, look at this. It's actually really cool. All right, see this WPY plus YPX? Well, look. Let me erase this for you real quick. Okay, look at this. WPX, YPZ. Look right here. Here it is. WPX, right here. WPY, sorry about that. WPY, YPX. WPY, YPX. Look right here. WPY, YPX. What does all of that equal? It equals WPX. So what can you substitute for this whole thing right here? Yep, you guessed it, WPX. Really cool. Now look at this. Watch this. See these three letters here, YPX, XPZ? They're right here. YPX, XPZ. All of this equals that. So what can I substitute for this right here? Yep, you guessed it. YPZ, YPZ. So you substituted. You took this whole phrase here, you crossed it off, and you substituted this. You took this whole expression, you crossed it off, and you substituted this. And that was our goal. Look what it says. Complete the argument to show that this is true. And there it is down here. And you gave a reason for every step all the way through. I need you to call me or email me if you have questions. Don't hesitate to do that. Please continue to work hard and study for your tests and quizzes and do all of your homework.